Okay, so the reactor pattern. Reactor pattern basically uh, it's a concurrency pattern in which a synchronous process is given a feel of an asynchronous nature. For example, let us suppose there are there is an interface. Okay, there is an interfacing class. There is an interfacing class for socket, a TCP IP socket that basically takes the raw data from the TCP connection. Okay, so it takes the raw TCP data and it does the processing on this data to identify to which session these data belong to. Okay, so let's suppose there is a proprietary protocol in the TCP that is using a TCP interface for communication, and there are several sessions that are running between two systems. Okay, and corresponding to each session there is a state machine in the system. Okay, so there is a state machine here, state machine 1, state machine 2, state machine 3. Now imagine how this interface is going to be implemented. Now since there is only one physical connection to the TCP interface, only one connection is there, so there is only one stream on which this class is reading the data. Also there is only one stream on which this class is writing the data. So this class is basically reading the data from the TCP interface in a sequential fashion, in a sequential manner. Okay, so basically this class is actually a synchronous, is reading data synchronously, and it analyzes that data to find out the session information, and using that session information it hands over that particular data, or you can call it an event, to appropriate session. Okay, and this session is handed over to a particular state machine, and this state machine feels that this is asynchronously receiving the event. Okay, so if the data is for some other session, it will be handed over to the different session, and likewise n number of sessions can be handled. So there is one synchronous process which is giving a feel of asynchronous nature to the application layer. This kind of pattern is called reactor pattern. Okay, so what you can say is, so what is synchronous over here? This reactor pattern is synchronous. Okay, so the class that is taking input from the TCP interface is actually implementing the reactor pattern. It is taking the data synchronously and passing it on asynchronously to other state machines or other sessions. This becomes very important, and I have seen this is implemented in various libraries. For example, this is implemented as a event loop in several systems. For example, you can take the example of ARI interface in the asterisk. Okay, so what is an ARI interface? It is basically uh, a WebSocket interface between the asterisk and ARI application. Okay, so asterisk is one system used in the telephony for making phone calls, SIP calls. Okay, so you can just call it some kind of SIP server, which is exposing some APIs on the WebSocket. Okay, so WebSocket connection is there between the SIP server, the asterisk, and the ARI server. Okay, so if you are not catching up with these jargons, then simply understand there is a TCP interface between this server X and this server Y. Okay, WebSocket is essentially a TCP connection, and on this ARI server there are several sessions. Okay, so for, let's say, one first session phone call, there is session 1. For second phone call, this is session 2. For third phone call, session 3. So likewise, if there are 1,000 calls going on simultaneously, then there will be 1,000 sessions running on this server, and the event from the SIP server can come for any of these sessions. What are those events? Events are like when the called party hangs up, or when the calling party hangs up, or when there is ringing event from the remote server. So likewise, there can be several things, several events happening on any session. Now here, this pattern is implemented by the module that takes into account the connectivity with the WebSocket. Okay, so there is a module in ARI server that keeps on looking for events from WebSocket in a synchronous fashion. So on this side, it implements a synchronous event loop. Okay, synchronous event loop, which is a blocking loop. And when the event is received, it parses that event and identifies the session. And depending on the session ID, it hands over that particular event to corresponding session. Okay, so this session now feels that it has received the event asynchronously, whereas behind the scenes we know there is a synchronous event loop. So here the reactor pattern has been implemented, and there are several examples, several libraries in production, and on internet also you can find that have implemented reactor pattern successfully. So it's a very important pattern for us.